Hi, everybody. We're going to get started. Thanks for coming to the Let's Automate It track. We're going to continue the chef server theme and have Andy and Nathan talk about monitoring and tuning your chef server.
Thanks, Ryan. So like Ryan said, we're doing monitoring and tuning your chef server. So if that's not what you want to see, then you should in the wrong room. And I'm Nathan Cerny. I'm a success team manager on the success team at Chef. And this is Andrew. He's a success engineer on the same team. And so we have a lot of enterprise experience monitoring chef servers and helping customers through issues caused by lack of tuning and lack of monitoring. So when you don't have monitoring, you're constantly fighting a battle against incidents and service interruptions. And we believe that monitoring is an art, but it's also fed and nourished by science. And so we wanted to kick off today by talking about the art of monitoring. Then we'll go into some of the deeper science and talk a little bit about tuning, and then show you a demo of a really cool monitoring environment that Andrew set up. But before we get started, let's actually define the problem that we're trying to solve. So we believe that, the problem we're trying to solve is that we need to make effective decisions and effectively respond to incidents. We believe that visibility into systems is necessary to make those effective decisions, and that monitoring provides that visibility. And when you hear the term monitoring, there's usually two things that people are actually talking about. One is reactive alerting. So you're actually getting paged out due to an incident, usually at 3 a.m. for some reason. Why does everything fail at 3 a.m.? I haven't figured that one out yet. And then business intelligence, which is an actual display of the metrics and data defining your systems so that you can make those intelligent decisions about them. You can identify trends and then proactively prevent issues. So you don't get paged out at 3 a.m. So the first guideline of monitoring is start small. Don't try to fix the world. What's the single most important thing that you care about? Is your application up or down? So that's probably the first thing you should write, so you get alerted if your application's down, because otherwise it's not going to do you any good. So once you have the very first monitor in place, you should start with the smallest possible monitoring profile that's useful. And I like to follow the 5-minute rule. So when you first get on a system, what are the things you do during the first 5 minutes to determine application health? Those are the things that I would start with by monitoring, so that you don't have to spend that 5 minutes when you first get on the system. Everything else you can build out later, but the next level of importance is instrumentation. So get all of the instrumentation that Andrew's going to set up, or you're going to talk about in a little bit, stood up so that you have that business intelligence for when you need it. Simplicity always outweighs perfection, and I have to be a little bit more clear now thanks to Adam's talk this morning. So a very common pitfall is to try to build the perfect system right out of the box. Perfect systems don't really exist. So simplicity drives, simple systems are easier to understand, they're less fault prone, and they're easier to reason about as humans, and all of that leads to stability. And in a monitoring system especially, stability is kind of important. So try to keep everything, both your monitoring systems and your systems in general, as simple as possible. That doesn't mean avoid complexity. That means keep things in a way that you can reason about them as a human, and where it makes sense to break them apart, break them apart. Don't build in complexity just to build in complexity. So the example I have is, if your application is only latency sensitive, why would you monitor network bandwidth? They're related, but it's not what your application actually cares about. For those of you who were at ChefConf last year, this was Adam's keynote last year. So don't worry about scale until you have a scale problem, and you probably don't have a scale problem. In the same way, don't over-architect your systems for problems that you don't have. Solve for the problems you actually do have. So when you're building out monitoring systems, build out those monitors once you've actually seen an issue. Don't try to correct or catch all the issues up front, because you can't, it doesn't work, and you'll end up writing things that don't behave how you expect because you've never been able to test them. And this problem, the one thing I believe over everything else is practice continuous improvement. So if you find things that are working, keep doing them. If you find something that's aren't, don't, stop doing them. If you run into an issue because your first alert told you the application's down, and you didn't actually monitor for the thing that brought the application down, that's the point when you should write that monitor. In an ideal system, in an ideal world, you'd only ever see an alert once, right? Once you have that alert, you'd fix it, and you'd never see the alert again. It would just be there to make sure you don't regress ever. Now, we're not in a perfect world. I don't have unlimited time or resources. I'm sure none of you do either. If you do, talk to me after, because I want to know your secret. So this is where that business intelligence first comes in. So as you're monitoring, if you leave these alerts in place, even after you fix them, or well, before you fix them too, then you can start prioritizing your work based on which things are actually keeping you up at 3 a.m. And you can fix the things that matter the most and continuously improve and get better by focusing on the things that matter. Alert fatigue is real. Can I see a quick show of hands? Like, how many of you guys get more than 20 emails in a day? Almost everyone, awesome. How many of you read an action on all of those?
Hey, we have an honest room.
That's awesome. So now imagine you're getting 50 or 100 or 200 emails a day. What are you doing with those emails? Yeah, I had a previous life, I had a job that literally said anything that came from my monitoring system got sent immediately to the trash. So why are we watching those? That's no one's reading them. Why have them? So if you see something that's firing frequently, those should probably be one of the first things you fix. And if it's something that was put in because someone wanted to fix the world right up front, that's not actually monitoring for a real issue, then it's probably just alert spam. You should just get rid of the monitor. And Andrew will talk more about that in a second. And the final slide before I turn the mic over to Andrew. So if you're only monitoring your Chef infrastructure, you're probably not getting a whole lot of value, because that's not what's making you money. So monitor everything. Your application is the most important. Chef is obviously important in that it prevents you from, when Chef's down, it prevents you from doing your job and making money. But it's not your most important thing. And on that same note, if you have a monitoring system in place that's meeting all your needs, there's probably not a reason to stand up a new one. And there's definitely not a reason to go and build an artisanal system specifically for monitoring Chef. Likewise, there's probably not a reason to build an artisanal system to monitor just your application. There's lots of tools out there that do 90% what you need, and you can just work with those. I prefer tools that give me a lot of flexibility without putting a lot of restrictions in place. And with that, I'm going to turn it over to Andrew.
Awesome. All right, cool. The mic's on. Wicked. I didn't mess that up. Yay. Hey, everyone. I'm Andrew. I'm a success engineer at Chef. And we're going to drill down into actually monitoring your Chef server now and some tuning steps after that. So have a kind of lame Sun Tzu art of war quote there. Who wishes to fight must first count the cost. I'm treating metrics as, counting the cost. So yeah, let's get going. So let's talk very briefly about what you should monitor. You have an operating system, you have hardware, you need to monitor that, right? I'm probably preaching to the choir here. I doubt there's many people in the room that aren't doing that, but I can't do a monitoring talk without stressing that, because even with that in place, a vast majority of our high severity support tickets that come into Chef are caused by disk space. So, I have to stress that. You want to be monitoring your CPU, so things like IO weight, steal, utilization, all that stuff. Memory, free memory, how you're swapping, all that kind of stuff. Your disk from both a performance standpoint and a straight up utilization standpoint, super important, right? Especially with Postgres running. Both the actual performance of that disk and how much you're using of it are very, very important. So please be monitoring that. And you have system logs, so you have kernel logs, you have syslog on your system. You want to be picking those up and using some sort of central logging solution to pull those in and make them searchable so that you and your devs can search those and find out what's wrong. Don't be the production team that hoards all the logs to yourself. Get some extra eyes on that stuff, right? I'm going to talk about a category I call supporting services, and this is stuff that is included in the Omnibus package with Chef, but other applications, they may be their own applications on their own. I'm calling them supporting services because they're needed for the Chef server to run, but they're not exactly like software Chef writes, right? So PostgreSQL, big one, huge one. We'll talk about some strategies to monitor that. Solr, there's some interesting JMX ways to monitor that, and I'll provide you guys some articles to go take a look at. Rabbitmq and Nginx. So those are some of the biggest supporting services we see people have problems with their Chef server. And then on top of that, you actually have your Chef application services. So we have application logs that come out of every one of our services. We have Chef and we have Bifrost. So I had to make some assumptions and do some things to actually stand up a monitoring stack for this. The biggest ones, I had to pick some tools. Chances are that you guys aren't running this exact stack in your environment, and I'm not advocating to go stand up all these tools. I'm just telling you that these are the ones that I used, and yeah, they're great ones. Show of hands, is anyone who's using Sensu here? Yeah, everyone loves Sensu, right? Does anyone want to volunteer a couple reasons why they started using Sensu? Sorry? Oh, because you didn't like Nagios? Okay. Good, yeah, good call. Any? Pardon? Yeah. Do you want to expand on that at all?
Right, so because I run it on standalone, right, where your clients actually talk to the Rabbitmq and your Sensu server doesn't have to go to your clients to initiate check.
Right, so it's almost like decentralized a little bit, right? Yeah, exactly. So it kind of eliminates some of the craziness that traditional monitoring tools kind of cause in environments, right? In cloud environments, I should say. Splunk is probably tied as one of the most popular centralized logging, operational intelligence, and big data tools, but I mostly think of Splunk as centralized logging. It does other stuff really, really well, but myself, I think of it as central logging. Grafana does really nice dashboards. StatsD is a listener that collects metrics and forwards them onto something else. And TickStack, so there's this thing called the time series database, and that basically stores your metrics for you. And that's what I picked to use for that. Again, I'm not advocating you go and install all these things in your company. If you have a stack that exists today, you may want to use that. So let's talk a little bit about how you actually instrument our Erlang-based services. We have two big ones, Chef and Bifrost, and both of them are instrumented with this thing called Stats Hero. And if anyone uses New Relic, you can kind of think of Stats Hero as collecting New Relic type performance metrics for our Erlang services. It's kind of like that. And Stats Hero is able to emit to a StatsD listener. So basically, with StatsD, you can forward that on to a bunch of pluggable backends. So let's take a look at some of the metrics that come out of it. You've got a namespace, a category, the metric that's coming out of it, the measurement, so this is 1200 milliseconds, and the metric type, and this one's a histogram. And then there's an example here, and it basically shows how you would actually enable the Stats Hero service to emit to a StatsD server. Then we have this thing called Folsom Graphite, and it basically tracks a bunch of our DB pool sizes, or we have this thing called Pooler that's an Erlang library that we use that creates bounded pools for various things, and including HTTP, thread pools, DB pools, stuff like that. And Folsom tracks how much of that is free or used, and we'll actually have some examples here. So Squirrel is basically our SQL library, and you can see that you would get an in-use count and a free count out of it. As well, we track our depth solver pool, and you would get like an in-use count and a free count out of that. So Pretty useful metrics, especially if you're seeing 500 errors coming into your chef server, and you can go and check and see some of your pools are full. And this is how you would enable it. And finally, we have application logs. So we're going to go to a log collector. You're going to use a full-featured log collector. You should be using something like Splunk or Elk or something like that. And all of our services, not just our Erlang-based services, are logging into var log ops code. All right, so let's switch to tuning for a couple minutes, and then we'll show you guys a Grafana dashboard with some of that actual instrumentation so you can see what it actually looks like. So the first thing I want to talk about is client-side tuning. And no one wants the thundering herd of elephants coming towards them, right? No one wants that. So use the splay. And also the default splay that comes out of the Chef client cookbook is like 5 minutes. Set it to something closer to your actual interval so that you actually spread those things out over the full range of your interval time rather than having that set to a more narrow band. Is anyone in here not using splay, like actually using Chef client in a cron and not having any splay? How do you find it? How many nodes do you have?
I didn't choose that.
Okay. We should talk after. Okay, cool. So there's a few other things that we can do from the client side to help improve performance on the Chef server, even though it's not server-side tuning. These things will help with your Chef server immensely. So with OHI, sometimes you need to do some tuning. If you have Centrify installed, I've had many customers that installed Centrify and saw their OHI objects grow from like 2 or 3K to up to 70K. So you can imagine when you have thousands of nodes and a 70K node object that gets transmitted to the Chef server on every Chef client run, every time you do a node.save, that is devastating, right? It's huge. So a solution to that would be to change your passwd plugin for OHI and instead just parse your etc password file, right? Also, if you're running in a really high load environment, you may want to use something like minimal OHI to only collect the things that you really, really need, like IP address and a couple other things. It's also an option. Always use partial search. If you're using full search, you're returning the entire node object on every search request. That is also a huge performance hit, both on Solr on the server and Postgres. Also, a cool thing to look at is safe search. It basically can cache like a result set for you, and if you drop below a certain number of those results, then it won't accept the new data set. And know what a dependency graph is and manage it. One of the worst problems we see is massive dependency graphs on the Chef server. So use stuff like environment cookbooks that are pinned to exact versions or environments that are pinned to exact versions so that you limit your exposure to bad dependencies. All right, let's switch to server-side tuning. I'm going to check my time here. All right, we're still good. All right, so we have a new HA model. Don't do DRBD anymore, please. If you're doing DRBD now, you should move it off it at your earliest convenience onto the new HA model. Basically, if you were at the last talk, Mark explained our original motivations behind DRBD, and in the environments that we originally designed it for, it works great. In the cloud or in Amazon, not so great. Almost everything is tunable. I remember this Simpsons episode where Homer is like, you know, the nuclear plant is melting down, and he's hitting all the buttons, and he has no idea what he's doing, and trying to stop the nuclear plant from melting down. Don't do that, right? Use some of the stuff that Nathan talked about. Have an analytical approach. Have metrics. Figure out what's wrong. Tune that thing. Have a hypothesis. Tune that thing. Don't just go tune all the things because I showed you how to do it. So everything you're going to tune is going to be in your chefserver.rb. There's a couple links at the top here. The second one basically spews out every config that you can possibly set, and sometimes doesn't even give you any context. Actually, most of those don't give you any context other than the name of the tunable. And there's some in there that I don't know what they do. So, I mean, if you're going in there and tuning everything, you're kind of taking your chef server's life in your hands. And then if something is tunable that's not there, it'll be in your attributes file in your private chef cookbook. And the private chef cookbook is basically what drives your chefserver.rb into your chef config. So, and I have an example here of how you'd actually tune a setting. We're going to take a look at the private chef cookbook in a second. So really brief glance at the Private Chef Cookbook. Basically, you can see that we're in a module called Private Chef, and for all of these config settings, we're creating a new mash. And that's really all that happens is Private Chef creates these mashes, it evaluates the chefserver.rb file, and then the settings that you have, so when you set opscode urchef key equals value, you're really just saving something into this opscode urchef mash.new. And then all of that gets merged into an object that is then consumed by Private Chef and by your chef server reconfigure run. And it's all driven by cookbooks, and it's all driven by templates. There's actually no magic going on here. It's all chef. I guess there's a little magic going on. But let's take a quick look at some of the low-hanging fruit that you can tune. So starting from where a chef client actually comes into where chef client request actually comes into the server, you've got a front-end server that's running, and the four services we'll take a look at here are Nginx, Bifrost, urchef, and the Auth pool. So Bifrost and urchef are two Erlang services. Nginx is a web server. And Auth is basically a pool of HTTP threads that exist between urchef and Bifrost to actually handle authorization requests. So for Nginx, you should enable your cookbook cache. What this does is allow Nginx to actually cache your cookbooks on disk instead of going back to your bookshelf service every single time. Paired with that, you want to set your S3 URL expiry to something bigger if you want to keep those on disk longer and prevent going back to bookshelf more often. For Bifrost, we have these bounded queues for our DB pools. So there's this queue size, this pooler timeout, and the pool size. And basically what they do is you have a bounded queue that's pool size. So if you have 20 of those, you can have 20 executing Bifrost SQL queries going on at a time. You have a queue size, so you can queue up a number of requests behind that. And then you have a timeout. From when something enters the queue to when something gets executed in the pool and returned to the client, it has to complete within that timeout. And that timeout shouldn't be more than a few seconds, really. And we really recommend, depending on the size of your Postgres instance on your backend, that this pool size be somewhere between 20 and 40 connections, maybe 20 and 50 if you have a really big Postgres instance. And then we recommend the queue size be 1 to 2 times the size of your pool size. And that's just so that we don't overload the backend Postgres instance with connections. And finally, we have the authorization service. So as you increase the number of connections, you should also increase the number of initial pool count, and max queue size. We basically find around 100 of these is like the magic number, depending on what you set that pool size to and how many connections you have going at a time. But there's some overhead to spin these authorization threads up, right? So they're Erlang processes, and it takes a little bit of overhead to actually spawn these. And having a bigger pool can basically just save you a little performance there. And finally, urchef. So I'm going to skip over the pooler timeout and the pooler queue size because they basically have the same rules as Bifrost. But when we take a look at the dep solver is very CPU intensive. And what we recommend is that your workers be equal to the number of CPUs on your machine, or the number of CPUs minus 1 if you want to save a CPU. So it's usually a good idea for OS type stuff or other processes that are running. And you also have this idea, there's also a timeout for that, sorry. So some people boost this timeout to unrealistic levels. Your client doesn't care after 30 seconds what its dependency set was. And you probably have a dependency graphing problem that you should be solving instead of increasing this timeout, right? I mean, you've got a bunch of other timeouts that are also affecting that. So setting that too high is just masking a problem. It's not actually solving the underlying problem. And then you've got this keygen cache size. And what happens is in Chef Client 11, the client asks for a key from the server. So the server has a pool of keys that it keeps ready to serve to clients. We changed that in Chef Client 12. Now we generate the key on the client side and provide the public key to the server. So it is it's not as important unless you have a big fleet of Chef Client 11 still running around somewhere. And we'll talk about the backend server and some of those services and what you might tune there for a couple minutes. So you've got this idea of checkpoint segments, which basically Postgres has this idea of write-ahead logs that it writes to disk, and then it commits those into the permanent tables on disk. So the default checkpoint segments, so each wall, write-ahead log is a wall, is 16 megabytes. And by default, Postgres only takes 3 of those before it tries to write them permanently. In a modern system, that's actually pretty small, right? 48 megs is not huge. So we recommend going up to something like 32. And checkpoint completion target, so this is when Postgres expects to be done writing the previous walls to disk through the next checkpoint segments. So, and I'm sorry if I'm not doing a great job of explaining that, but basically it's usually at 0.5, so halfway through writing the last set of write-ahead logs onto disk, it expects that it's going to be done, the previous set. So we recommend once you have something a little larger with checkpoint segments, increasing this to something like 0.9 so that you can be 90% of the way through your next set of checkpoint segments. Gives you a little breathing room and gives Postgres, if there's something else happening on disk or if you're having some sort of storage issue, it gives it a little bit of time to correct itself. And finally, something that I think everyone should set is logmin duration statement. I guess not finally, but logmin duration statement. And what that does is actually write a log with all long-running queries on your Postgres instance on your Chef backend. And usually set this to a couple thousand milliseconds, right? So a couple seconds, so that you get all queries that are happening on your Postgres instance that are taking longer than a couple seconds. Finally, we have this max connections. You need to do a little math to figure this out. So it's the number of Bifrost DB pool members that you have, plus Urchef DB pool members that you have, times the number of front ends that you have, plus about 20. In case you want to connect with pgadmin to check something out, you should have a little bit of room for Administravia and other services that need to connect. Finally, we have Solr, I guess second last. We have Solr, which the 2 things that we see that need to be tuned are heap size and new size. So with heap size, we limit Solr's heap size in our config to 1 gig, and that's usually the first thing we see fall over on a Chef server cluster that's growing. If you have, say, a 16 gig backend Chef server, what I would recommend is that you bump this to 2 or 4 gigs manually in your chefserver.rb. And new size by default is 1/16 of the total heap size.
With a maximum of 32 meg.
Okay, so it's 1/16 of the total heap size with a maximum of 32 meg. Because we do a lot of writing, every time you index a node, or every time you have a Chef client run, a new node data shows up, it gets indexed into Solr. Bumping that can be helpful to not run out of new generation Java heap. And finally, Rabbitmq, there's not a whole lot that we tune here, but a couple things you should know. Your analytics max queue length should be set. You should have your queue cap there because it's going to, if you don't, it can fill up your Chef server, the Chef server's disk, and everything goes boom. So you should not let that happen. And the other thing, if you're not using analytics, there's this thing called dark launch, which actually disables the, if you set dark launch analytics to false, it'll actually prevent the launching of that Rabbitmq queue. So you save a little bit there. So I've got a bunch of helpful links here, mostly some Sensu plugins like Postgres, Rabbit, Solr, Nginx, file system checks, and then also a link to StatsD, Influx, and Splunk. Some more useful tools, so PG Badger, it basically takes all of your Postgres logs and does a whole bunch of graphing for it. So it's really cool. If you've never used it, and you have like a free lunch or something, it's even cool just to see what your Postgres instance is doing. There's a great Postgres.org article about monitoring your Postgres server, and they talk about write-ahead logs and checkpoint segments in way better detail than I can. How to monitor Nginx. I was a huge Apache guy before I came to Chef, and everything the Chef does is in Nginx. So I had a little transition period there, and Scalar has a wicked guide on how to monitor Nginx. So you definitely check that out. pgtune, it's a Perl or Python, I can't quite remember right this second, script that basically Postgres is kind of designed to run on minimal hardware, or it can run on minimal hardware. So the default configs are kind of set to that. And it takes those wimpy default settings and beefs them up for you. But one thing to note, it expects that the only thing you'll run on that system is a Postgres server. So it's not really great when you also have a Solr server there. So take that with a little caution. If it tells you to use like 80% of your memory for Postgres, scale that back to like 40%, right? Just use a little common sense with that. And finally, if you're having Solr garbage collection issues, there's the GC viewer, tested, tried and true. If anyone's run Java apps, they've probably run into this at some point. And it basically collects you just take your garbage collection logs, shove it into it, and it graphs out how long you spent in each type of garbage collection, stuff like that. All right, some alternative tools. Who here runs an elk stack? Sweet. Who runs Splunk? Yeah, it's like a 50-50 split almost. So anyone using Graylog? We had someone on Monday. But Loggly? How about Graphite or Datadog? Yeah, cool. Yeah, so I mean, there's so many tools out there, right? You have a smorgasbord of options right now in this space, and I wanted to stress again that just because I'm up here talking about these specific tools, don't feel that you need to go back and install all these tools. I wanted to give a couple special thanks. Irving from Chef, he is awesome, and he wrote this blog called Tuning the Chef Server for Scale.
Required reading.
Yeah. I had to fit this into like 25 minutes, and that is like the current source of truth for a lot of stuff on tuning your Chef server. So please go there. The dashboards I'm going to show you, Mark Harrison, Paul Mooring, and the Chef server, the hosted Chef team, and the Chef operations team, they're heavily based off some of the dashboards that they created. So big thanks to them. They saved me so much time and messing around in Grafana. And Phil Dibowitz and Facebook taught me a whole bunch of stuff about tuning a Chef server that I had no idea even existed because I went through some stuff with them in the last year. So yeah, we're going to switch over now to a live demo. This demo is driven by a chef provisioning recipe that I have on GitHub. You're more than welcome to go check it out. I just committed all the changes I made in the last couple days up today, so it's nice and fresh. It needs a little more work. I need to start driving by chef search and a couple other things, but it's in pretty good shape. So yeah, we're going to switch out here. I'm going to let Nathan take over. Yeah, I'll get it on the right window. All right, so I guess just to show you guys what I'm doing, I'm going to run a Chef Server Coddle test. And what this will do is test every single API endpoint on the Chef server to make sure it's working. And that'll generate some metrics for us to actually take a look at. Unfortunately, I don't have a load tester running right now, so this will kind of generate some load and give us some good metrics. And I just totally messed that up. All right. Yeah, good call. All right, so we switched to a mirrored display, and you can see we just ran Chef Server Coddle test, and I'm going to let Nathan take over driving here. But we started to get metrics immediately. And if you want to scale it down to like 5 minutes, it'll show us a little more granularity. Yeah, there we go. Cool, so this is Grafana. If anyone hasn't seen it, this interface is Grafana. And this is being fed data from InfluxDB running a Graphite listener. And you can see that we have an overall API response time metric that's coming in, and we're getting some useful stats out of that, including some means and including the 90th percentile metrics that we need to see what the longest running queries are taking. If you take a look over here, we've got request rate by status code. So when we look over here, you can see we've got a whole bunch of 200s and 201s. There's an expected 404, so it's important to talk about that, right? When you begin collecting metrics on this stuff, don't Don't create an alert for every 4xx or 5xx response code. Some of them are expected, and you're going to drive yourself crazy. Those 200 emails a day Nathan was talking about, that's how you generate that, by alerting on every single bad response code. Find out what normal levels are for your Chef server when users aren't complaining, and then start creating alerts based on that. You can see that we get total requests, and this is gauged in a request per second. So you can see that at the beginning of our test, we were getting about 20 to 25 requests per second, and it's trailed off because the test is probably completed now. And we start to get pretty granular here. So we get mean response times by upstream. So if we, are you going to stop that? Yeah, go ahead. So we're going to stop the auto refresh so that the metrics we have don't slide off the screen. Yeah, so we have mean response time by upstream. So you can see that we have Solr, we have our authorization service, we have the depth solver. So basically how long it takes each of these pools to actually respond. Cool, so then we have mean response times by service. I mean, this is getting really granular, right? You have a service, so every time we hit the client's endpoint, and every time we post to it, so when we try to create a new one, we can see how long that's taking. In a mean response time type of way. And this exists for every API endpoint and every HTTP verb that hits the Chef server. So you can get really granular with how long each service is taking.
This graph is not good complexity?
Yeah, so we were talking about this morning. Probably in a future version of this dashboard, I'll split this out. So there's like an API dashboard, and then each grouping of services is its own graph so that you don't get that kind of sprawl, right? So this will be kind of a moving target as we keep going, but it's in a pretty usable state now. So finally, you can get requests per second by service as far as these are all statsd implemented and stats hero implemented things. And you can see that each service is named here and how long it took. And if we scroll down, we've got basic HTTP response code type stuff. So you can see we've got no 500 responses, but we've got a bunch of non-200 responses. So requests per second. I don't know how you get 0.2 off the top of my head, but anyway, you do somehow. So I guess it's aggregating over a short period of time and saying that in one of the last 10 seconds, you had a 404. All right, cool. There's two other dashboards that I'm including that we're going to take a look at. So that was overall Chef API. There's a Bifrost API one. This is, and that's set to 6 hours right now. So basically, you get the same kind of thing, overall API response times, status codes, total requests, and non-200 response codes. So you can, again, use this as kind of a quick health check. And finally, there's, actually, I think that's it. Yeah, that's it. So there's also a reporting dashboard. I only have Chef Server Core installed on my VM, so we're not going to have any reporting metrics, but there is one more dashboard there. Cool. That actually brings us to the end. Yeah, just so you guys can see the GitHub. So I've kind of laid out my plan here in a README, and you can go see how crazy things were. At one point I was using Graphite, I tore it out. Don't look at the commit history, it's like all over the place. Like, so basically I started out using Graphite and found out that Carbon is really hard to scale, or not really hard, but it's complicated to scale Carbon. So I was like, all right, no, I'm gonna switch to InfluxDB. Anyway, questions? Yeah?
Where can I find the slides?
I'll probably do a webinar and then post them. So do a webinar of this at some point, and then on the Chef webinar thing, and then I'm not sure yet, but keep an eye. I'll put a link to them when I put them somewhere. I'll put a link to them in the README here. Okay? So keep an eye on that README. I'll put them there. Anything else?
You can probably put them up on SlideShare.
Yeah, probably SlideShare, and then I'll put a link to the SlideShare from here. Cool, well, how are we doing? Yeah, 3:38, perfect. Nice. Cool, we'll be around if you guys have any questions. Really, this is meant to be like a reference cookbook that you can take and use. Awesome, thank you.